Okay, now we uh, have live in YouTube and go back to Zoom. As you know before, my name is Hazrul Iswadi. I am an industrial engineering lecturer actually, but my expertise is mathematics. So Mr. Nyoto and Mr. Joko asked me to teach you in this course. Now we will talk about linear algebra. So this is the full screen of the slide. Okay, and we have 7 chapters in this course. Chapter 1 talk about matrices and systems of linear equation. Chapter 2 talk about determinants, and chapter 3 talk about vectors in 2 dimension and 3 dimension, and chapter 4 talk about vector space. Then chapter 5 about inner product space, chapter 6 about linear transformation, and the last about eigenvalues and eigenvectors. So there are 7 chapters for this course, and uh, the the composition of the chapters for before midterms and after midterms follows. Chapter 1 divided into 3 weeks or 3 meetings. Week 1 to week 2. Week 1 we will do in this morning, and week 2 about linear equation system, and week 3 about homogeneous linear equation system. And chapter 2 divided into uh, two meetings or 2 weeks, and chapter 3 in week 6. There are 3 assignments, assignment 1, 2, and 3, and we just pick 2 assignment, the best assignment out of 3 assignment. And you must do quiz in this week 7. Week 7. Quiz and assignment conduct online. So actually you do exercise for assignment, but for assignment you have longer time. Maybe for one day you can solve the problem of assignment. For quiz, only 1 or 2 hours. So this is subject matter after midterms examination, week 8 to week 14, and also you must do quiz 2 in the last week in the 14 week. Then there are also 3 assignments after midterm examination. Assignment 4 to assignment 6. So this is how we grade you. This NTS, nilai tengah semester, or what we call mid-term score, is equal to 20% assignment plus 20% quiz and plus 60% examination. And examination and quizzes are conducted online. For assignment, we just pick best two out of three assignment. And all of course materials, discussion of quizzes or discussion of examination, grades, and other announcements, we can be access at ULS. So all of the infos are in ULS. There are two references for this course. The first is linear algebra module, but we find difficulty to send this module for all of you because this module in the hard copy. We think difficult to send to you. Alternatively, you have this book, the following books, authored by Howard Anton, Chris Flores, and Anton Keul, uh, titled by Elementary Linear Algebra. And I thought this book have been sent the link. I have been sent the link in the night in the yesterday night. So if you don't have or you don't know the link of this book, you can ask me later how to find this book. Okay. Please give a response or ask something about the introduction. If you have any question, please ask me. Yet, clear or what?
Okay, sir.
Okay. Yes, I think especially me have some difficulties to speak flexible in the first meeting, and naturally, but for the second meetings, third meeting, and the next, I think I I will be more flexible, and I think also for you. Okay, but it's okay. We must learn together how to make our communication more flexible. If you don't have any question, I will continue to the material of this course in the week one. As I told in the yesterday night, uh, you must prepare Padlet and Symbolet in your browser, because in the end of the meeting, in the end of this meeting, we will do some exercise about matrices and operation of matrix. Okay, we start the course. We will talk about matrices and a system of linear equation. And especially in this morning, we will talk about matrices and operation of matrix. We start with the definition. Definition of matrices. Matrix is a set of elements arranged according to regular rows and columns in a rectangular shape. So the emphasis on the rectangular shapes and elements, or in some case, some books say that entries, elements or entries can be numbers, real or complex, can be function, or can be others with notation bracket, regular bracket. This is the regular bracket, and the others is the rectangular bracket, rectangular bracket. And uh, notation of matrix symbolized by this one. Sorry, symbolized by a capital. This is capital A, and there are other symbol here. Subscribe. Uh, M times N means that M's the rows, it should be, must be S here. Sorry, must be S here. And uh, N indicate columns. Yeah, columns. If we write the entries of elements of matrix, we can write like this. This is the entries in the one on one position, position. It means that first row and the first column, and this is A12. Sorry, A12 means that in the first row and in the second columns, and this is indicate that in the first row and in the nth column, and so on. This is the symbol of elements of matrix. This is, for example, it means that the entries of the entry or elements in the M rows and the second row, the second column. Sorry. Then we have some names for matrix. If M equals N, then we call matrix as square matrix. Square matrix. If M equal to 1, we call matrix as row matrix. And others, if N is equal to 1, we call matrix as column matrix, because only one column. This is only one row, and this is have same number of column and same number of row. Okay, this is just a name. Now we will talk about types of matrices. Types of matrices. The first, we have a diagonal matrix. Diagonal matrix means that square matrix with element Aij is equal to 0 for I is not equal to J. So we don't mind about the position I equal to J. We just consider about the rest where I is not equal to J. So this one must be 0. I will I will talk more about diagonal. There are two kind of diagonal. The first from upper left to the lower right. This is diagonal, but also there is a diagonal from below left to the upper right. Uh, for this one, we call as ordinary or diagonal, ordinary or so, ordinary. Sorry, my pen is not too ordinary diagonal. This one we call as a main diagonal. So main diagonal. So this diagonal more special than this diagonal. Okay, you must remember this one called as main diagonal. Main diagonal. Okay, let we continue for the second type of matrices. Uh, we have a scalar matrix. Scalar matrix is a diagonal matrix. Sorry, this is must be X. Diagonal matrix where the elements in main diagonal have the same value. For example, this one we call as a scalar matrix. This in the above matrix is not scalar but diagonal because the element of uh, the element in the main diagonal is not uh, is not equal. Okay. Then more specific than scalar matrix, we have identity matrix. Identity matrix. Identity matrix is a scalar matrix where the elements in main diagonal are one. So must be specific to one. And for example, this is the identity matrix. Uh, Sometimes we symbolize this matrix by I. I, in this case, we can symbolize by I3. I3 means that the size is 3 times 3. Then we also have, for example, I2 must be identity matrix with the 1, 0, 0, 1, and so on. So we have I4 maybe. I4, it means that we have 1, 0, 0, 0, 0, 0, 1, 0, 0. Sorry, my pen tablet is not too fluently, too fluent. 0, 1, 0, 0, 0, 0. Wow, 1. So this is I4 and so on. Okay, cannot us admit this meeting. And in the fourth, we have upper and lower triangle, or triangular. I should check this word, triangle or triangular. Yeah, there another triangular. Sorry, my triangular matrix. Upper or lower triangular matrix is a square matrix where every element below or above of main diagonal is zero. So they emphasize on the below and above main diagonal. And if the elements below diagonals, main diagonal is zero, we call upper. So for example, this one, because in the below of diagonal, main diagonal is zero, so this is low upper triangular matrix. And the opposite, this is lower triangular matrix because
Um,
the the elements above of main diagonal is zero. This is below lower, sorry, and this is upper triangular matrix. Okay, is there any question? I hear some voice.
so
Yeah,
for how to spell it, it should be triangular, so not triangular, so triangular.
triangular.
Yes,
Okay, yeah, something like that. Triangular, triangular, isn't it?
not with g, so with g,
Isn't it?
with g.
Yeah. Triangular. Is it correct?
Yes, sir.
Okay, triangular. Yeah. Then we uh why there is a playing music. No. Okay. And next we will talk about transpose matrix. Transpose if A is any matrix m times n, then AT defined as a matrix n times m. So you can notice that the size is different, m times n, and the others n times m, which is obtained by swapping rows and columns from A. That is the first column of AT from the first row of A, or comes from, maybe, comes from the first row of A. And the second columns of AT comes from the second row of A, etc. So if we have this matrix, this is the first row becomes the first column for AT, and the second row of A becomes the second columns of AT. Also, the third rows of A become the third columns of AT. Okay, I think it's clear because easy to make transpose matrix. And the properties of the transpose matrix as follow. Transpose of transpose of matrix is equal to A. So we can delete the double transpose here. And the second, if we sum, or if we add A to B and transpose them, we is equal to A transpose add to B transpose. and the rest. You can use these properties to calculate the operation of matrix related to transpose matrix. Okay, then we continue for the six types of operation matrix. We call as symmetry matrix. A is called a symmetry matrix. Oh, sorry, it should be here maybe. No, matrix. Symmetry matrix. If for every I and j applies aij is equal to aji. If A is a symmetry matrix, then we have this property. Their transpose is equal to A itself. Look at this example. We have matrix B, and if we make their transpose, its transpose, we have this this matrix, and we can look at that B is equal to B transpose. So matrix B is symmetry matrix. Okay, after we know some types of matrices, we will talk about operation, matrix operation. And the first, we must know the equality of two matrices. Two matrix, two matrices, yeah, maybe. A and B is equal if the sizes are the same and the corresponding elements are equal. So the entries or elements in the same position must be equal. For example, this one, we have matrix A and matrix B, and the position in the 1, 1, 1, 2, and 2, 1 is equal, but in the last, in 2, 2, we have x in A, we have 5 in B. So to make A equals B, we must have x must be 5. For the others values of x, matrix A and B are not the same. no value of x makes A equal to C, because size of A is not equal to C. The second operation is addition matrix. Two matrices can be added if the sizes are the same. So this is the first one. We must check the size are the same and the elements are the same as the sum of the corresponding. So we must add to the same position. So here C must be equal to sum of A and B. Look at this example. We have three matrices A, B, and C. A have the same size with B, but it's not equal size with this with C. So we only we only add A to B or B to A, but not A to C, because A and C uh, have no same size. So this is cannot be operated. We can only operate uh, one and C, one and three. The properties of addition matrices can be seen in this following list. A plus B is equal to B plus A, and these properties is called commutative, and these properties are called as associative, and zero can be seen as identity matrix for addition. And if we have A plus B is equal to 0, so B can be is called the inverse with respect to the addition of A. The symbol for B is minus A. Okay, I think this operation addition is not too difficult. You must be carefully. You must be careful with this operation. We call the multiplication of matrices. Uh, Matrix A can be multiplied by matrix B if the number of columns of A is the same as the number of rows of B. So before you multiply two matrices, you must check these properties. The number of columns of A is the same as the number of the number of rows of B. Look at this example. Matrix A have four columns, uh, four columns, and matrix B have four rows. Four rows. So we can multiply A uh, uh, and B. But we cannot or we can multiply B to A. So in general, okay, this is the explanation. So in general, we have these properties. A times B is not equal to B times A in general. In general, it means that maybe we can have the equality in some cases, but for general, we don't have the equality. So this is the explanation how to do multiplication of matrix. So, for example, we have this matrix and A, and the second matrix is B. Then we do A times B. For example, we multiply a second row with the third column. Uh, we must multiply 2 by 4 plus 6 by 3 and plus 0 by 4 by 5, and the result is 26, and we put 26 in this position. And also, for example, we multiply first row with column here, fourth column. So we have 13. And the rest, if we calculate all of them, we have A times B as follow. This is A times B. I hope you also you get this explanation in the senior high school or before or junior high school maybe. And the properties of matrix multiplication we call as close. Close means that if we multiply A by B, we must have matrix, and this is called by close tertutup. And associative, left distributive, and right distributive. So this is some properties of a matrix multiplication. You can use these properties when you do some calculation of matrix multiplication. Then multiplication matrix by a scalar. Scalar mean uh, real number. Then multiplication of matrix with this scalar. We symbolize by RA is equal to this operation. Every elements of A times to R. So we have elements of B. And the properties of multiplication matrix by a scalar as follows. I think it's also not too difficult to understand because this is only can be done by logic, not to strength, I think. We have three matrices in this example. Then we can do some operation, multiplication by a scalar. For example, 3a. 3a means that all every elements of A multiplied by 3. I try to make it for 3a. Every elements of A multiplied by 3 means this is must be 6, yes, and this is 9, okay, and this is must be 12. This is 3, isn't it? And 9, and the last 3. Is it correct?
Yes, sir.
Okay. Then also for 2 and 3, you can do it by yourself. Uh, okay, we uh, have some exercises here. After this exercise, we also have some problems in Padlet. Now we try to. I want ask you uh, to solve this problem. I give you 10 or 15 minutes maybe to solve this problem. Uh, but how to check in? Oh, okay, later maybe. Please just do in your notebook this problem to solve 1, 2, and 3. There are 3 problems here, and do it in your notebook. And I will ask you maybe randomly what the answer for this problem. Please do maybe 10 or 15 minutes. Please don't be hesitate if you want to ask me something or don't know how to solve this problem. You can write in the chat room if uh, want to ask something, or raise hand, or ask directly. Please don't be hesitate. Okay, is there any solution? One of this problem? What about 1A?
Can I answer it, sir?
Yes, please.
It's 14, 3 minus 1, 8.
14,
3
3
minus 1,
minus 1,
8.
8. Oh, it's, yes, it's correct.
So can I share my screen, sir?
Okay, I stop here. I stop my screen share and please, okay, let's,
This is my BC, sir.
uh-huh. BC, okay. Uh,
So it's -7, -6, 15,
minus
2, 3, 10.
6, yeah, 6, 15, 3, 310.
Yes, sir.
Okay. This is 2A, is that it?
Yes, sir. 2A, sir.
2A. And B cannot be done. And C,
I'm not done, sir.
oh, okay, okay.
Yeah, we should stop it.
Okay, thank you. Okay, others?
So I think I can do number 1B.
Numbers?
1B.
1B,
All right.
1B, okay.
So
What
the x
X
equals to
is?
3.
Mhm.
Y equals to 4.
Y is equal to 4. Okay, correct.
Okay, thank you, sir.
Yes. No. Then we still have to C, to D, and uh, uh, 3, number 3.
Two kali 0.
Sir, can I answer 3A?
Okay, Kathleen.
The answer is for 1 minus B. Then
1 minus B.
for the first row, then
Mm-hmm.
A plus 1,
Mm-hmm.
then minus 1.
Mm-hmm. Sorry, 2 or 3? 3.
3A.
3A. 3A, it must be B transpose, isn't it? So there is a wrong notation here.
Yes, sir.
Uh,
So change to B.
okay, thank you. It's correct. Okay, to 2C, 2D, 3B, and 3C. That are for remaining problems. If you don't mind, you can share your screen so that others participant can view your solution. Okay, parallel with the work with your working in this problem. I will share about symbolic, how to use symbolic for this problem. I try to solve 3B by using symbolic. I choose where is okay this one matrix. Have you do you see my screen in the web in the browser?
Not yet, sir.
No, sir. No, sir.
Okay, it must be stop the screen share first and go back to the this one. Have you seen?
Yes, sir. I can see it, sir.
Okay, this is the symbolic. I want to solve 3B. 3B, I must input maybe this one. 1A and 2 for the first matrix. And for the second matrix, I must input 1 times 3, B minus 1 and 3. So the multiplication is this one. So we have the result is matrix 3 times 3. 3 times 3, B minus 1, 3, A times B minus B, 3A, and so on. 2B minus 2 and 6. Now you can look at if I make a different position, this one, B times A, we have different result, and the result is this one, B minus A plus 6. So you must be careful with the multiplication of matrices, because A times B is not equal to B times A. Okay, you can write in your notebook the solution of 3B here. Okay, Michelle, write for 2D. 2D, okay, 10, 10, 3, 1, 7, 5, 8. And this is for, I, I must check it. D, 2D, 3A plus CT. Okay, it's correct. Thank you, Michelle. Okay, you all the problems still remains for to C and 3C. Okay, 3C from Kathleen. A is equal to minus 2 plus 3, or over by divide by 3, and B is equal to 3 divided by 2. And Gabriel say that to C is sorry, CA. Okay, you make two rows. Yes, isn't it? 9,
Yes,
10,
sir.
and 15, 7. Okay.
Yes.
Okay. All correct. Thank you for your participation. Then all of this problem in this exercise have been done. We must go to the Padlet and prepare for the Padlet, please. Okay, I must share Padlet, and please go to the Padlet in via ULS. This is the Padlet. Sorry. Okay, here. Okay, this is Padlet for on.
Can you show it? So, I mean, show it to us, the file.
Should must be stop screen first, maybe. Yeah. Okay. Can you see?
Yes, I can see it clearly. So, and can you show it?
Okay, this one.
Yeah.
For you, you can go to the ULS and please click here or here maybe in common chalkboard week 1, and in your screen will be show will be shown like this. And if you want to make it bigger, you can click the problems, and you have a bigger picture here. So please do it, and I suggest you using Symbol Lab or other computer algebra software, because for example in problem 6 you have big matrix, and you must do a big number of calculation, or if you do by hand, and please do it by computer algebra software. And please, if you don't mind, answer this question by using the facility in this Padlet. Click in plus sign in the below right, like here. Then you can write maybe answers of question 1, maybe like this, and write your name and your student number 1604 20 XXX, maybe, for example, maybe Kenneth, like here. So after that, you can upload your answers. There are some facility to upload your answers. You can do it by file. You can also take a picture, take a photo. Maybe you can write it by hand. In this example, you can write like this: -1, 2, 3, 4. After that, you click uh, save here. After you click, I can see your answer, and others also can see your answers. So this is our common chatbot.
Excuse me, sir.
Yes,
Can I ask? In my Padlet, I don't have that plus symbol on bottom corner.
really,
Me too, sir.
really.
Yes, sir.
Oh, so I don't know. Maybe the settings. Try to ah, this one. Okay, have you?
No, sir.
Refresh maybe.
We can comment on your post, but we can make a post.
Oh, okay. So where is the comment? Comment. Mhm. Hmm, where is the facility for posting? Hmm. Okay, I try to use Padlet in my other gadget. Wait a minute. Uh, I try to I try to send in my other gadget, and there is no. Okay, how to be. Hmm, what should I hope you can give a. What should I do? Hmm, have you any experience in this application?
No, sir.
Mhm. How to
Sir, maybe the plus symbol only appear for the creator of the Padlet page somehow. I think it's only appear for your page and
Hmm.
not appear for ours.
Okay. So I try this one maybe. Uh, Mm. Okay. Hmm. Yeah, yeah. Maybe. So, uh, your ULS is still empty. Okay, maybe this one, maybe. Um,
Yes.
I think it's izin bagi pengunjung, sir.
okay, maybe this one, yes. Yeah, like this one
Yes.
can be editable, isn't it? Yeah, please. Um, please refresh, maybe.
Yes, sir. I can see the plus sign. So,
Still?
I'm already can see.
Ah, okay. Nah, okay, that's yes. You can. Okay.
Sorry, sir. How to add the note, sir?
Just who make this?
Me,
Please.
sir.
Yeah. Gabriel, what you do?
I want to answer the question for
Hmm.
1A and B.
One A and B. So Lukita, you can click plus sign in the below right.
Um,
Have you see? Have you
no,
seen?
sir. No, sir. There's no plus sign, sir, in mine, sir.
Okay. What about Gabriel? How to see sign plus signs?
I don't know, sir. I just refresh my website and then the plus button is appear.
Oh, yeah. I see that.
Ah,
It's appear.
yes. Can you, Ligita?
Yes, I can see.
Okay. Okay. Please do the answers based on the problems. Oh, 1A. 1A. Please write your name, Gabriel. Okay. Okay. A 1A. It means C, C21 and C13, isn't it?
Yes, sir.
Yes, sir.
Okay. Next, the rest.
See two
Okay.
one.
Answers. Okay, Kathleen using photos uh, for uh, sorry, I don't see. What numbers you're solving problem, Kathleen?
Number 8.
Number eight. Oh, number eight. Number eight. A, B, and A times B, so that you have A, B, C, D. Okay. A, B, C, D, E, F. E, F. Where is E, F? Not yet.
The
Only,
question only tell us to do
oh,
column 1 and 2.
oh, see, I see. Okay. Yeah, it's correct.
Minus 15.
Mhm.
5.
Question 3. Okay, either in chat. Mm, I have a problem when I access my URS. The site can be reached, and it cannot be reached. Mm, I don't know how to. Have you typed the right address? Zenhub?
Yes, sir. I typed the right address
Or
at the same as when I
ULS?
tried to open it. Excuse me, sir.
ULS dot ubaya.ic.id, isn't it?
Yes, the ULS one dot
Oh,
ubaya
no,
dot
no,
h.
no, without one.
Oh, okay. All right. Okay.
Okay, without one.
Okay, sir.
Mhm.
Okay, now I can access it, sir.
Okay.
Oh,
Yes, Lukita, what happened?
no, so I just learned how to post it, so
Yes, you must learn it by using some. There are some facilities, I think, you can use it. as comfortable as you have. Okay, you uh, use file, and this is the answers for question 2, 5A, 2B, and C is 5A plus 2B, and the answer is 2255 minus 35 minus X, 27. Okay, 32 minus 27, and so on. Sorry. Okay, it's correct. Lalu kita okay, Kathleen try to make uh, another solution. Um, okay, and from Kathleen for the answer of uh, from Kathleen, we have the answer of question nine, and U V and multiplication of U transpose by V. Uh, we have minus 2A plus 2B, okay, 3B minus 4C, okay. And the other position, V transpose times U, we have minus 2 plus 3B minus 4C. Okay, same. And multiplication of U times V transpose. Kathleen have the matrix 3 times 3, and V times U transpose, also matrix 3 times 3. Yes, okay. So we must be careful with the size, isn't it? Uh, U transpose times V, we have scalar or matrix 1 by 1, and others we have matrix 3 times 3. Okay, good. Okay, then to question. Gabriel also 2 question. Question number 4 and question number 1. Kenneth 1 question. Michelle do question number 5. First column. First column means that you must multiply first row with the uh, column, first column, second row to the first column, and third row to the first column too. Okay, 0, 0. Wait a minute, 0. I think, okay. Can you check again, Michelle? Can you check again, Michelle, for question number 5? Okay, please check again because I try to multiply first row uh, with the first column. It's not correct. For 0. Okay, Kenneth. Try to find the solution for number 3. Number 3, solve. Okay. X, Y, and W. X, Y, W, and Z. What you find? X is equal to 1. Z is equal to minus 1 a quarter. Then this is okay. Wait a minute. I try to put your solution in the problem. Okay. Minus 1. Then Y, W, 1, and minus 1. Okay. I try to make a confirmation. Minus 1. Minus 4. Okay, yes, correct. Check it for Kenneth. The answer of question 3 is correct. And the rest, what else? Zenhard, any progress?
Wait, sir. I'm still looking for to answer the explain.
Okay. Kita make the correction for question number 5.
Excuse me, sir.
Mhm.
For the question on the number 10, is it
Yeah.
that I have to give an explanation with the example or just an explanation, sir?
Just an explanation, I think, because hmm, sorry. Can you explain it, or you must write by numbers? I I hope you can just. I hope you make an explanation.
So it doesn't need an example, sir.
Mm, yeah, don't make an example in mathematics. So we uh, if we make an example, uh, it is dangerous because uh, we must generalize in mathematics. We must generalize everything in mathematics. So this question asks the explanation. Yes, you can you can answer by this explanation too.
Okay, thank you, sir.
Yes. Okay, Michelle said that the question mean minus 8 or 4 and minus 20. No. Okay, in the first column, isn't it, Michelle? Yes, you can. Yeah, yeah. Okay, okay. Thank you. And Lukita also answers number 5, and you both of you have the same answers: minus x, 4, and minus 20. Okay, thank you. Good. So um, I can erase your answers, Michelle, here. Okay. Yeah. So this is I make um, Michelle. Yeah. Because Michelle also Michelle. Is it Michelle? 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 Double L? Yes. Michelle. Okay. You we have one, two, three, four, five, six, seven, eight answers. I'm still waiting for Zenhard. Can you write the explanation?
Uh, yes, sir. I still looking for the right one. So I still try to looking the right one.
Okay.
Oh,
Yes. Okay. This is uh, Kathleen try to solve the big matrix in this problem in the matrix in the question number 6, and this is the answer of Kathleen. You can look at the pattern. The what we call the strip of one move to the upper, as two. We have sorry S square in matrix S square. We have the strip of one move to to upper level, one upper level, and S cube further to upper, and as fourth, the fourth root, the as to the fourth, we have only one elements have one what we call one, and after uh, S to the fifth, S to the sixth, and so on. The matrix have zero in all of their entries, in all of their elements. So there are good patterns here. The strip of one move upward, and from S to the fifth and S to the sixth, and so on. The matrix have all of the entries zero. Okay, nice patterns here, and correct. Thank you, Kathleen, for your answer. Only two remains answers, 10 and 7. Okay, Zenhard and Lukita, you can send your answer later, because we will close this meeting now.
So how to
Okay,
change the
please.
number into decimal, so in the symbol lab, so
Decimal point, maybe you can write point.
so I just need to change it to point.
Uh-huh.
Okay.
Yeah. Okay, I close this meeting. Before it, I close this Padlet also, to make sure that there is nobody edit this Padlet. Where is the here maybe? Oh, sorry, I forget. I forgot where is the how to make it. Anyone remember how to modify
On
this?
the undang orang lain section, sir.
undang orang lain, oke. And then no. Here maybe.
Yes, that one, sir.
That one in the privacy, is that it?
Yes.
Yeah. This one I close it. Only read, yes. Cannot be edited anymore. Sorry. Okay. So the sign plus in your screen disappear.
Yes, sir.
Okay, yes. Okay, thank you very much, and I am glad you have good participation in this class. Keep it for the next meeting, and thank you for your participation today. And see you next meeting. And bye bye.
Thank
you,
you,
sir.
See you,
sir.
sir. Thank you, sir.
Thank
Thank
you.
Thank
you,
you,
sir.
sir.
Thank you, sir.
Thank
Thank
you,
you.
sir.
Yes, welcome.